Assalamu alaikum guys, welcome back to BioBlitz Universe, and in today's lecture we're going to do past papers of heat capacity. So let's start. Now we'll do the first past paper which I have taken out from May June paper 2008 2007. It is, what is the definition of heat capacity? So what is the definition of heat capacity? We know that heat capacity is the heat heat given to the object to raise its temperature by 1 degree Celsius. So now let's see. Let's go into the A. The quantity of heat required to raise the temperature of an object through one. Yeah, this is the definition. So by this A is correct. We don't need to go to B, C, D. But let's check out B, C, D. So B is the quantity of heat required to raise the temperature of 1 kg through 1 degree. So it means that it's not heat capacity, but it is specific heat capacity because it comes 1 kg. The quantity of heat required to convert an object. So this is basically latent heat. Okay, this isn't without a change in temperature. This definition is of latent heat. This isn't of heat loss. The quantity of heat required to change 1 kg of substance from solid to liquid without a change in, and this is, I think, specific latent heat, something like that. So if you look at question 2, it says in an experiment to find the specific heat capacity of metal, it is found that 5,200 joule is needed to raise the temperature of a 2 kg block by 20 degree. What value for specific capacity is given for these results? So if you know the formula of specific heat capacity, it is equal to C Q upon M delta T, right? So C is the specific heat capacity. Q is the heat supplied. M is the mass. Delta T is the change in temperature. Okay. Now if you put the values, we don't know C. We know heat supplied, which is 5200 joules to raise the temperature of a 2 kg by 20 degrees. So change in temperature is 20 and mass is 2 kg. So if you put these values in a calculator, the answer is, let me check it out. It is 130 joule per kg degrees Celsius. Okay. So if we look at the first option, it is 130 joule per kg degrees Celsius. Okay. Now this is solved. Yeah. So now if you look at question 3, a 2 kg mass of copper of specific capacity of 400 is heated for 80 seconds by heater for 850. What is the rise in temperature? Rise in temperature means change in temperature, right? So for change in temperature, the formula will be Q upon MC. If we just like move this, and so the derived formula becomes Q upon MC. Now, by the way, we don't know Q because we know mass, right? We know C, the specific, and but we don't know Q. But we have a formula for Q, right? Q is equal to what? Q is equal to MC delta T. But in this, we don't know delta T, right? So we can't use this formula. But there is some other formula, which is Q is equal to power times time. As we know power, it is also present, and we also know that heat is also present, time is also present. So by this, we can find the heat, which is power is 50, and it multiplies with 80, we will get the heat, which is, I think, 4,000. Yes, it's 4K. So we found the heat. Now let's put the values. So delta T is equal to 4,000 upon M. M is 2 times C is 400. So it becomes so the answer is 5K. Okay. So the answer will be 5K. And we are done with part 3. Now let's go on the question 3. Now let's go on to question 4. A cup of tea at 80 degrees Celsius is left to cool to 20 degrees Celsius. If the heat capacity of cup and tea is 4 kg, how much heat is released during the cooling? Now, this is a good question. not like hard, but it is a good question. So now, the change in temperature in this part will be 80 minus 20, which will be 60, right? So 60 is the change in temperature, the data if we look at it, and heat capacity is 4. Okay. Now heat release means the heat Q is basically required. So, okay. Now if we multiply 60 with 4, the answer will be 240. Okay. Okay. Q is equal to C times delta T. Okay. In this question, the formula will be like this. And the answer is 240, and hence D is the answer. Now let's move on to 5. When heat is applied to a metallic sphere, which of the following changes will occur? The mass of a sphere increases, the volume of the sphere increases, the density of the sphere increases. So as we know that whenever heat is applied to any object, its internal energy will always increase. So hence D will be the answer. Okay, that's simple. That's a fact basically. Okay, using an electric kettle, 100 gram of water at 100 degree is converted into steam at 100 degree in 300 seconds. The specific heat capacity of steam is this. What is the average electrical power used? So, what is the average electrical power used? Now, this is a calculation-based question, I guess. So, basically, if we see there's a concept of latent heat and some calculation is also. So, in now the new syllabus latent heat is not included, hence we will not. Now we will do question number 9, okay? Because, or it's basically question number 7, but I haven't added. I think it's a typing mistake. Okay. Now, in this question, a 2 kg mass of copper is heated for 40 seconds by heater that produces 100 joules. So, we got the mass heated for 40 seconds that produces. So, we got the energy which we multiply 40 by 100, which is equal to 4,000. Okay. And the specific capacity of heat is 400. Okay. Rise in temperature. So, if you see rise in temperature, the formula is delta T upon Q upon MC. Okay. So, So we know Q which is 4,000 upon M which is 2 and C is 400. If we solve it, the answer is 5 and A is gonna be 5K. Yeah. Heat energy is supplied at the same rate to 100 gram of paraffin and 200 gram of water in similar containers. Why does the temperature of the paraffin rise more quickly? The paraffin has a larger specific heat capacity than water. The paraffin has a smaller specific capacity than water. The paraffin is less dense than water. The paraffin is more dense than water. So what can be the answer in this question number 10? So the paraffin, so the answer, part B can be the answer because paraffin has a smaller speed capacity than water. It can make sense because it has a smaller specific capacity than water, okay? And hence its temperature rise more quickly. Now let's go to question number 11. A block of water has a mass of 2 kg. Its specific heat capacity is 800. The block supplied The block is supplied with 2400 joules of energy. What is the rise in temperature? What is the rise in temperature means delta T. So again, the formula is delta T upon Q upon MC. Now the block of metal is M is 2, C is 800, and Q is 2400, right? Now let's put them in the formula. It is 240, 2 times 800. By this, what we will get is, let me check in the calculator. So we get 1.5. Okay. So the answer is, wait, where's the pen? Yeah. The answer is 1.5 degrees Celsius. Okay. Now part C is basically the right answer. Now we're done with the past papers of specific heat capacity. I hope you guys got like have got uh the questions and have understood it well, inshallah. So now that's it for today, guys, and Allah Hafiz. And we'll meet in the next lecture soon, inshallah.